Hi guys, so I'm back with the sharpening skill series. So let's go to a new question called as small factorials. So you are asked to calculate factorial of some positive integers, an integer t which is in between 1 to 100, denoting the number of test cases followed by t lines. Each line containing a single integer n, which should be between 1 to 100. So for each integer n given an input, display a line with the value of n factorial. So basically we have to find the factorial. So let's go to our Sublime Text setup and start solving the question. So let's add in our basic code of taking the input from input and output file. So first of all, let's also take the input. So here t and n are given. So first of all, t test cases int input, and then for I in range t, we will take n int input. So let's define a factorial function, and we will use recursion. So this all recursion, backtracking, all stuff will be cleared in the data structures and algorithm, which I am planning to make a series on. So it will be cleared in that series as well. Here we will take a basic understanding how it works. So let's use a pass and then take a parameter n and call here factorial function. So factorial of n. So here what we have to basically do, we have to return the value of n into factorial of n minus 1. So basically, what is factorial first of all? So if you are given a number n, so let's consider, so if you are given a number n, then n factorial is equal to n into n minus 1 factorial. So basically, for example, if we take 5, then 5 factorial is equal to 5 into 4 into 3, 5 into 4 factorial, and then 4 factorial would be 4 into 3 factorial, 3 factorial would be 3 into 2 factorial, 2 factorial would be 2 into 1 factorial, and 1 factorial or the 0 factorial. So 1 will be 1 into 0 factorial, and 0 factorial has the value 1. So we know 0 factorial is equal to 1. So this becomes 4 into 5 4s are 20, 20 into 3 60, 60 into 2 120, 120 into 1 120. So this basically gives us value 120. So what we have to do, first of all, take the value n, reduce it by 1, and apply the same logic of factorial again. So if we start as n equal to 5, so 5 into factorial of 4, so 4 into factorial of 3, and so on. So if we consider any n and then reduce it by 1 1 1 1 1, so we have to stop somewhere. So we have to stop when n equal to 1 or 0, means we have to stop when the n equal to 0, because 0 factorial value is known as 1. So what we will do, basically recurse, means we will repetitively perform some function, just changing the parameter. So we will call this factorial function again and again recursively and find out the value. So first of all, we will return n into factorial of n minus 1. So if this goes on continuing, then we have to give an stopping condition. So in the recursive function we have to always specify some stopping condition, because if we not specify any stopping condition, then this function will goes on recursively n number of times. So let's see an example. If we run this, see, you can see recursion error, maximum recursion depth exceeded. So Python recurs a function up to 999 times. So if 999 times a function is performed, same function, then it stop execution and gives an recursion error. So you can see here, previous line repeated more than 996. This is 996 and these are the 3 calls. So it is called 999 times. So let me maximize this. So here you can see these are the 3 calls and these are 996 more times, means total 999 times Python called this function, but after that also it has not stopped. So we have got an recursion error which says maximum recursion depth exceeded, means Python is throwing an error that it thinks so you have not provided any stopping condition, and which is true in our case. We have not provided any stopping condition. So for providing a stopping condition we can use conditional statement if n equal to 0, or we can say if we get 1 also, then also we can stop, because 0 factorial and 1 factorial are the same thing. 1 factorial is 1 and 0 factorial is also 1. So if n is equal to 1, then we have to return the value 1, else we have to go on recursion. We have to recursively use this factorial and find out the value. So let's take the value 5. So 1 5. So now if we run this, we have not printed the value. So as we have used here return, so this function will return a value. We can directly print it. So print. So you can see 120 got printed and 5 factorial is 120. So this is the basic understanding of recursion. So let's take the input here and see how it works. So let's run this. So 1 factorial is 1, as we know. 2 factorial is 2 into 1 factorial, which is 2 into 1. 5 factorial, as we see here, is 120, and 3 factorial is 3 into 2 into 1. 3 2s are 6, so 6 is the answer of factorial. So I think so the code has been created. So let's copy this and go to the submit section and let's submit this. So we got status correct answer, so our program is accepted successfully. So let's see another approach. Instead of using recursion, as you are a beginner, you can also use an recursive call. So let's comment this out and then let's create a function. Let's use recursive call. So for we don't know when to stop. So when we don't know when to stop, we use while case and then give a condition. So while n is greater than 0. So let me just a second, we will improvise this condition. So we will improvise this function. So here we are only checking n equal to 1. So if n is given as 0, so let in this case take 0 and then run this. So it will again give an recursion error, as we have specified only condition 1, but here it is taking n as 0. So n is not equal to 1, means 0 is not equal to 1. So what happens, it will go in else condition, and 0, minus 1, minus 2, minus 3, and it goes on up to infinity. So we can modify this condition. If also instead of 0 we use minus, means negative integers, then also we will get the same error as recursion error, maximum recursion that exceeded, because we have only given the condition that n, if only n is equal to 1, then we will return 1, but it is not the case. If it is 0 also, or it is a negative number, mostly negative number we don't find an, so we can modify this case to, if n is less than or equal to 0, then we will return 1. Means if we get -5, then n is -5, n is less than 0, condition satisfies and returns an 1. So if we also put a 0 here and then run this, you can see it will successfully run, because -5 factorial is given as 1 and 0 factorial is also given as 1. So this becomes a good program, as it supports the edge test cases, which are -5 and 0. These edge test cases may be in your hidden test cases, so due to which your program may fail. So these things come in some medium level questions or hard level questions, so they give the edge test cases where your program might fail. So this is an improvised factorial function. So let's go to our old iterative version. So let's try our iterative version. So while n is greater than 0, so while n is greater than 0 or equal to, both condition can satisfy, because 1 and 0 both gives the same output as 1. So while n is greater than or equal to 0, we have to, let's take a variable answer equal to 1, as we will be multiplying it. If we take the 0, then anything multiplied with 0 gives us 0, so we would need 1. So answer times equal n. This is basically, this means answer equal to answer times n. So this basically means the same, both statements. So the answer times n, so answer will be multiplied by n, and then n equal to n minus 1. So means we are decreasing the value of n for each loop, and then at last let's return answer, return. So let's try this out. So we are getting a 0 answer. So equal to 0 is the condition, so last value of n becomes 0, and then answer becomes totally 0, because anything multiplied by 0 is 0. So let's run this. Now see, you can get the correct output 1, 2, 120 and 6. So this code can also work. This is an iterative version of this same factorial code. So let's copy this, go to the submit section, comment this out, paste our iterative version. Let's remove these comments and let's submit this and check whether it works perfect or not. Yes, correct answer status is been returned, means this also satisfies, this also successfully answers the program, answers the question. So that's all for this video. Let's meet in our next video.